Hi guys, welcome back to Part 2 versus YouTube channel where curiosity meets the code. Today our topic of discussion will be large language models, that is LLMs. So let's start with the contents. So starting we have introduction, then we have evolution of the language models, then we have GPT 3.5 architecture, training of process, language generation, conversational AI, limitation of LLMs and ethical consideration. Then we have transfer learning, fine tuning, open AI's policies, real world implementation, future developments, challenges in scaling, security concerns. So what is LLMs? So LLMs are advanced artificial intelligence models designed to comprehend, generate and manipulate human-like text at an extensive scale. And then we have size and complexity. LLMs are characterized by their vast parameters and intricate architecture, enabling them to capture intricate patterns in language. And then we have examples. What are the examples? Like ChatGPT 3 to amplify the class of models. Next, we have role in understanding and generating human-like text. So firstly, we have comprehension. LLMs excel in comprehending context, semantics, and nuances in human language, enabling more sophisticated language interaction. And then we have contextual understanding. Their ability to understand contextual relationship contribute to more accurate and context-aware responses. Thirdly, we have create generation. LLMs are proficient in generating human-like text from coherent sentences to creative writing, exhibiting a level of language fluency. Then we have adaptability. Their adaptability to diverse writing style and topic showcases their capability to enumerate human-like expressions. Next, we have evolution of language models. So firstly, we have transformation catalyst. Advancement in computing explore how improvements in computing power played a pivotal role in transforming language models such as data availability. Discuss the impact of increased data availability and its role in training more complex and context-aware models. Thirdly, we have algorithmic innovations, highlight how algorithmic innovations such as deep learning contribute to the transformative journey. Next, we have paving the way for large language models. Convergence of factors emphasizes how the convergence of computing power, data availability, and algorithmic innovations pave the way for emergence of large language models, which is LLMs. Then we can define the characteristics, outline the defining characteristics of LLMs, such as their ability to handle vast amount of data and generate coherent and contextual relevant text. Next, we have key milestones in development. So, introduce the audience to significant milestones that marks the evolutionary journey of language model. Then we have revolutionized movement showcasing key breakthroughs, innovation or model release that have revolutionized the landscape of language modeling. Next, we have the most important LLMs in today's world, which is GPT 3.5 architecture. So the overview is it's a generative pre-trained transformer. 3.5 represents a pinnacle, a large language model architecture. Then transform framework. GPT 3.5 is built upon the transformer architecture, a revolutionary framework in natural language processing tasks. And then we have parametric scale, highlighting the massive scale of parameters in GPT 3.5, distinguishing it as one of the largest language models to date. Next, we have components and layers in models. Firstly, we have attention mechanism. Introduce the attention mechanism, a crucial component in GPT 3.5, facilitating contextual understanding and informing flow. Secondly, we have encoder-decoder layers, highlighting the presence of multiple encoder-decoder layers, each contributing to the model's depth and complexity. And then we have embedding layers, illustrate how embedding layers convert words into numerical representation of fundamental steps to language modeling. And then we have positional encoding, explain how positional encoding helps the model understand the sequential nature of language. Then we have unprecedented scale. So one is parametric size, provides specific figures on the numbers of the parameters in GPT. 3.5 showcasing it unpredicted scale. Then we have computational power, emphasize the colossal computation power required to train deploy GPT 3.5 contributing to its effectiveness. Next, we have the training process for LLMs. Firstly, high level um, explanation, delve into the training process where large LLMS models undergo a complex journey to grasp the number of human language. Then we have objective function, introduce the concepts of an objective function, guiding the model to minimize the difference between predictive and actual outputs during training. Then we have back propagation, highlighting the interactive nature of training, where back propagation fine tunes the model based on errors identified in previous iterations. Next, we have massive scale data and computational resources. Firstly, we have data as the foundation, emphasizes the significance of vast data sets comprising diverse linguistic patterns and contexts as the foundation of LLM training. Then we have computational resources, discuss the momental computational resources required for training, showcasing the parallel processing capabilities that accelerate learning. And then we have parallelization techniques, brief touch upon parallelization techniques allowing LLMs to handle large data sets efficiently. Then we have fine tuning and adaptability. Fine tuning process introduces fine tuning stage where LLMs adapt to specific tasks or domains by adjusting parameters. And then we have adaptability, highlight the adaptability of LLMs, enabling them to excel in diverse applications from healthcare to finance through targeted fine tuning. Then we have transfer learning concept. Touch upon the concept of transfer learning where pre-trained models leverage existing knowledge to excel in new tasks. Next thing is language generation. So firstly we have text generation capabilities, versatility, highlighting the versatility of a larger language models in LLMs in generating diverse forms of text. And then we have dynamic output, showcasing the dynamic and contextual aware nature of LLMs in generating human-like text. Next, we have creating writing. Introduce creating writing as a process of crafting imaginative and expressive contents. LLM's role is to illustrate how LLM serves as a creative writing tool to assisting writers in indentation, style, emanation, and overcoming writer's block. Example showcase example of creative pieces generated by LLMs to demonstrate their creative potential. Next, we have content creation, diverse content types, explore how LLMs contribute to creating various content types, example from blog posts and articles to making marketing copy, quality enhancement, discuss how LLMs enhances content quality by offering suggestions, refining language and adapting the different writing style. Then we have time efficiencies, emphasize the time saving benefits of using LLMs in content creation workflows. Next, we have story generation. So, story generation as an automated creation of narrative content. What are skills here? LLMs can generate a coherent and engaging narratives, making them valuable tools in storytelling. What are the applications here? Potential applications in generating interactive narratives, claim plot lines, or personalized storytelling experiences. Next, we have conversational AI, which is the hot topic of the coding world. So, firstly, let me give a brief introduction of conversational AI. It is a seamless integration of artificial intelligence into the systems, empowering them into engage in human-like conversions. Then we have the objective of it. It highlights the goal of conversational AI is creating an interactive and natural dialogue experiences. Next, we have LLMs in conversational agents and chatbots. Role of LLMs, explain how LLMs play a crucial role in empowering conversational agents and chatbots. Then we have natural language understanding emphasizes LMS ability to understand and respond to user inputs in natural language, enhancing the conversational experiences. And then we have adaptability, discuss how LLMs adapt to diverse user queries, making them versatile tools for interactive interfaces. Next, we have enhancing user interaction through natural language. We have firstly user-centric interaction. LLMs contributes to how user-centric interaction by understanding and responding to natural language queries. And then we have personalization, the potential for personalization and conversation, creating tailored and engaging user experience. So some of the real world applications include virtual assistant, customer support chatbots, and interactive interfaces that benefits from LLM driven natural language interactions. Next, we have the limitations of LLMs. Firstly, we lack of real world understanding. Description: LLMs may struggle to comprehend real world contents, leading to response that lack practice relevances. Example: difficulty in understanding nuanced information or evaluating the situation. Secondly, we have sensitivity to input phrasing. So, LLMs can exhibit sensitivity to slight changes in input phrasing, potentially yielding different responses. Example: minor rephrasing may lead to inconsistency of variation in model output. Thirdly, we have ethical consideration, biases and fairness. LLMs may exhibit bias in output, raising concerns about fair representation. And in case of mitigation strategies, ongoing efforts to mitigate bias and ensures the ethical usage. The next thing which comes up is user awareness and transparency. User may not be fully aware of the limitations of LLMs, necessitating transparent communication. And then we have initiatives to educate users about inherent constraints of LLMs to overcome this. Next, we have continuous research and collaboration. Overcoming LLM limitation requires ongoing research and collaborative effortlessly. And then we have future direction, which is encouraging collaboration between researchers, developers, and users for collective improvement. Next, we have the ethical consideration. Firstly, we have bias mitigation. The issue with this is LLMs can perpetuate biases from training data, and the second is ethical focus is mitigation bias to ensure fair and unbiased model outputs. Second, we have transparency challenge. We have LLMs often lack transparency in decision making, and we have addressing transparency concerns for increased accountability. Thirdly, we have privacy safeguards, which is issues is LLMs may handle sensitivity data. Ethical focus is implementing robust privacy measures for data security. Next, we have transfer learning. So, one of the important features in LLMs, firstly, we have knowledge transfer. Transfer learning in LLMs involves pre-trained on a large dataset of for a general understanding of the language. The benefit of this is allow for model to acquire broad linguistic knowledge before fine-tuning for specific tasks. And then we have adaptability to tasks. LLMs can leverage pre-trained knowledge to adapt various tasks with minimal additional training. And what is the advantages? It reduces the need for extensive task specific data and accelerates the training process for new application. Thirdly, we have efficient resources utilization. Transfer learning optimizes resources utilization by utilizing pre-existing knowledge. The advantages of this would be enhances efficiency, especially in scenarios with limited computational resources or data availability. Next, we have fine tuning. Firstly, we have task specific optimization description. Fine tuning involves training a pre trained large language model, which is LLM, on a smaller task specified data sets, and we have purpose is to tailor the model to a specific application, enhancing performance on targeted tasks. Secondly, we have adapting to context. We have fine tuning allows the LLM to adapt its lean features to nuances the requirement of a particular task or domain. Flexibility enables the model to capture task specific patterns and improve contextual understanding. Thirdly, we have balancing generalization and specificality. So, fine tuning strikes a balance between leveraging pre trained knowledge and adapting to task specific requirements. The benefits of this is to preserve the generalization capabilities of a pre trained model while enhancing performance in a forced context. Next, we have open AI policies. So, firstly, we have access to models. OpenAI embraces broad access to its models to encourage exploration and innovation consideration, balancing the accessibility with responsive use and potential risk. Secondly, we have safety and ethical use policy. OpenAI is committed to safely required users to adhere to ethical guidelines in use of their models. Ethical focus, encouraging the responsible AI practices and preventing malicious applications. Thirdly, we have collaborative development. OpenAI prompts collaborations with the research community to collectively address challenges and advanced AI technology. What are the benefits? It fosters a collaborative environment for shared learning, improvement, and responsible AI development. Next, we have real world implementation. Firstly, we have content generation. So, large LLMS modules excel in generative adhesive content, including articles, creative pieces, and marketing, copy, streamlining content creation process. Secondly, we have chatbots and virtual assistants. LLMS power chatbots and virtual assistants offering a natural language interaction for customer support, online services, and interactive applications. Thirdly, we have code generation and programming. LLMs are instrumental in code generation tasks, assisting developers by suggesting code snippets, providing improvements, and enhancing overall programming efficiencies. So, what are the future developments in LLMs? Model scale and complexity. The anticipated development, future large language, which is LLMs, are expected to surpass current scales, pushing the boundaries of complexity and capabilities. Next, we have the impact. Increased model scale may enhance language understanding, context, retention, and generation of more contextual relevant text. Next, we have multimodal capabilities. So we have anticipated development. Future LLMs are likely to incorporate multimodal capabilities, combining text understanding with image and possibly audio processing impact. This integration can enable more comprehensive AI application, including improved content understanding, enhanced chatbots interactions, advanced advancements in image captioning. Next, we have domain specific specialization. So, LLMs may evolve to offer domain specific specialization with model tailored to excel in particular industries or knowledge domain. And specialized LLMs can provide more accurate and contextual relevant information for specific applications such as healthcare, law, or finance. Next, what are the challenges in scaling LLMs? Firstly, we have computational resources. The challenge being scaling LLMs requires substantial computational resources, including powerful hardware and high-end performances, computing infrastructure. Secondly, we have implications. Limited access to such resources can hinder the wider spread adoption and development of extremely large models. Secondly, we have energy consumption. This challenge here will scaling LLMs often leads to increased energy consumption during both training interface. So second one will be implications. High energy consumption raises environment concerns and poses challenges in deploying large models on a global scale. Thirdly, data requirement. This is the most difficult one as of my knowledge. So the challenge being scaling LLMs demands extensive training data sets to maintain model performance and prevent overfitting. Secondly, we have implication obtained the curating large and diverse data sets for training can be challenging, especially for niche domains or languages. Next, we have the security concerns for LLMs. Firstly, we have adversarial attacks, which is a very large common or vulnerable LLMs to adhesive attacks where malicious crafted inputs can lead to unexpected or incorrect outputs. And what are the implications here? Adversarial attacks poses risk in various applications, including misinformation based responses, biased responses, and compromised security. Second being privacy risks. LLMs may inadequately reveal sensitive information present in their training data, raising privacy concerns. Secondly, we have implication protecting user privacy becomes a crucial, especially when LLMs are used in applications that involve handling personal or confidential data. Thirdly, we have model output interpretability concerns. LLMs often operate a complex black box models, making it challenging to interpret and understand the reasoning behind their outputs. Implication would be lack of interpretability can raise ethical concerns and hinder the ability to identify the address biased or undesired behavior. So this is it with LLMs. Comment down below which will be the next topic that you want me to discuss. Thank you so much for watching. If you have learned something from this video, please do like, share and subscribe to our channel for more such information.